If someone told you that for just over $83,000, if you could own a Tesla super electric plane, most people would probably laugh or think it's impossible. But not long ago, many said the same thing about electric cars. 15 years ago, the idea that battery-powered vehicles could rival gasoline cars sounded far-fetched until Elon Musk and Tesla proved otherwise. Now, that same spirit of disruption is moving to the skies. The Tesla super electric plane isn't just about another mode of transportation. It represents a complete shift in how we think about flight, bringing together affordability, efficiency, clean energy, and intelligent automation in ways that could rewrite the aviation industry. The $83,595 price point alone is enough to make headlines. It's a shocking figure when compared to traditional small aircraft, where a Cessna 172 can easily cost between $400,000 and $600,000. And higher-end models like the Cirrus SR22 exceed $1 million. By undercutting these prices by more than 80%, Tesla is doing what it always does best, forcing the rest of the industry to rethink what's possible. This single number opens the door to pilots, flight schools, small businesses, and even families who previously could never imagine owning or operating a plane. For many, it's the equivalent of buying a luxury car rather than an aircraft. The affordability doesn't stop at purchase price. Operating costs are where the Tesla super electric plane truly starts to show its strength. Traditional aircraft rely on aviation gasoline, which is both expensive and environmentally harmful. An average piston engine plane burns around 10 to 15 gallons of fuel per hour, costing anywhere from $70 to $120 an hour just in fuel, not including maintenance or insurance. Electric flight flips that equation because of the efficiency of electric motors and regenerative energy systems. Tesla's plane can operate at a fraction of the cost, possibly under $20 per flight hour. This reduction means pilots can fly more often, flight schools can train more students, and small air service providers can offer cheaper routes and tours. It's a game-changing formula: low purchase cost, low operating cost, and zero emissions. But even with all those advantages, one major challenge has always held electric aviation back: charging time. If a plane can't recharge quickly, the savings vanish as aircraft sit idle on the ground. Tesla's solution? The Air Supercharger network. Building on the foundation that made Tesla's EVs so practical, Musk's team is adapting their fast-charging technology for the aviation world. The Air Supercharger stations use ultra-high-capacity chargers with both ground-based and solar-assisted power, capable of recharging aircraft batteries in minutes instead of hours. Imagine landing your Tesla plane, plugging in at a regional airfield, grabbing a coffee, and taking off again within half an hour. No waiting for refueling trucks, no oil checks, no exhaust. Tesla envisions a seamless digital experience where each flight's data connects automatically to the company's ecosystem. Pilots would plan routes in the Tesla app, receive real-time weather updates, and even reserve charging slots in advance. With Starlink integration, these planes could stay connected mid-air, syncing navigation and performance data through low-latency satellite internet. This is how Tesla turns what looks like a product into an entire system, a full ecosystem that connects power generation, flight operations, and software intelligence. And that's the real secret behind why companies like Boeing should be nervous. Boeing's world revolves around complex supply chains, high manufacturing costs, and long development cycles. Tesla, by contrast, thrives on vertical integration, automated manufacturing, and constant iteration. Scaling up production, of course, will be Tesla's biggest hurdle. Aircraft certification, regulatory oversight, and safety standards make building planes more complicated than cars. But Tesla's track record with ramping up complex manufacturing gives it an edge. When the Model 3 was first announced, critics said Tesla could never mass-produce affordable EVs at scale. Today, Tesla churns out millions of vehicles annually, with some of the most advanced factories in the world. The same playbook: gigafactories, robotized assembly lines, rapid feedback loop scan apply to Aviation too. Tesla has already developed the technology backbone that will drive this scale: modular battery packs, lightweight materials like aluminum and carbon fiber composites, and AI-driven quality control systems. Each of these technologies shortens production time, cuts costs, and boosts reliability. For instance, Tesla's 4680 battery cell design, which drastically reduces weight and manufacturing complexity, can be adapted for aviation use. Paired with advanced cooling systems and structural battery integration, it enables planes that are both efficient and strong. But none of this means much if flying isn't safe. That's where Tesla's heritage in software and autonomy steps in. The company's self-driving AI, refined through billions of real-world miles, provides a foundation for flight automation. While Tesla isn't turning its plane into a fully autonomous aircraft at least not yet, it's making flying dramatically simpler. Features like AI-assisted takeoff, automated stability control, smart route optimization, and predictive maintenance are part of the design. The onboard system continuously monitors weather, flight paths, and aircraft health, alerting pilots long before issues arise. Think of it as autopilot for the sky. A new generation of pilots will be able to focus on navigation and decision-making rather than mechanical tasks. And as the regulatory environment evolves, full or partial autonomy could reduce pilot workload even further. The result? Fewer accidents, lower training barriers, and greater accessibility for new flyers. What's more, Tesla's plane would likely tie into its existing software ecosystem. Your Tesla app might one day show both your car and plane in one interface: battery levels, flight history, weather alerts, and maintenance reminders, all synchronized in real time. The synergy between Tesla's ground and air transportation systems could redefine how people think about personal mobility. Picture driving your Model 2 to a small airfield. It's taking off in your Tesla super electric plane, flying hundreds of miles for less than the cost of a tank of gas. It's not just about individuals. Flight schools could replace fleets of gas-powered trainers with quiet, emission-free electric models, cutting fuel costs by up to 90%. Air taxi services could use these planes for short regional hops, linking rural areas with cities at affordable prices. Emergency responders could deploy them for search and rescue, or medical missions with near-silent flight and minimal maintenance. Each application expands the market and strengthens Tesla's ecosystem. All this adds up to a massive disruption for legacy aerospace giants like Boeing and Airbus.
Boeing
Has spent decades focused on large passenger jets, defense contracts, and traditional propulsion systems. Its business model depends on complex supplier relationships and costly production lines. Tesla's approach: lean, flexible, data-driven, operates in an entirely different paradigm. If Tesla can mass-produce safe, certified electric aircraft at under $100,000, it opens a completely new market segment: affordable, personal, and regional aviation. Boeing might still dominate the skies for intercontinental travel. But Tesla's goal isn't to replace jumbo jets, it's to replace car trips and short-haul flights under 500 miles. That's the sweet spot where electric propulsion shines. With lower energy costs, fewer moving parts, and instant torque, electric planes are ideal for short hops between cities. Tesla's vertically integrated business model also means it can control every part of the process, from energy generation via solar panels to storage and power walls, and megapacks to consumption by its vehicles and aircraft. It's a closed-loop ecosystem where every component supports the other. The electricity that charges a Tesla car can just as easily power a Tesla plane. The AI that drives an autonomous car can guide flight operations. Data that optimizes battery life on the ground can improve range in the air. No traditional aerospace company has that level of integration. The implications reach far beyond transportation. This shift could also redefine regional economics. Airports that once struggled with noise or pollution restrictions could welcome electric planes with open arms. Smaller communities could regain direct air connections, creating new tourism and business opportunities. Electric flights, quietness, and lower maintenance costs make small airports economically viable again, with Air Superchargers placed strategically around the world at airports, heliports, and vertiports. Tesla could create an entirely new energy network that doubles as infrastructure for its future electric helicopters or vertical takeoff jets. As for safety and certification, Tesla's methodical, data-driven development process might actually accelerate approval. The company's history of real-time monitoring, constant over-the-air updates, and predictive diagnostics could become a blueprint for aviation compliance. Instead of static maintenance schedules, Tesla aircraft could rely on continuous condition monitoring, reducing downtime and increasing safety margins. Still, the challenge of scaling production will be enormous. Aviation requires stringent standards and highly skilled assembly. But just as Tesla turned the auto industry's skepticism into admiration, it might do the same with aviation. The company's rapid prototyping approach, testing, learning, and improving in short cycles means its first electric aircraft will likely evolve quickly.